So I just introduce. So I just introduce a very specific application of behavior informatics or behavior analytics in a specific area actually related to every one of us. That's a tax. I introduced this specific application from three perspectives. So one is that what is the problem faced government and the solutions we provided. And then the second part is about some specific and simple case studies and outcome. And then I briefly introduce the methodology behind. So in Australia last year, 2016, so that the tax debt was quite small, actually just 19 billion, but actually quite big for Australia, such a small country. And the government face this problem is to detect the debt and to prevent and intervene, but to understand who, which client and who and why, caused this debt and what they did and when they did and what the government can do and when would be the best time, the right time and right action and to intervene with those people, including like at what time to call who, those kind of things. And there are three specific business objectives I show here. So one is that the government wants the taxpayers to pay the tax or lodge their tax on time and to predict the clients who are more likely to pay that in full before the due date, to identify differential treatment for self-finaliser and non-self-finaliser. I will explain what is non-self-finaliser and what is self-finaliser, and adjust the government policy and process to interact with the specific people. The second business objective is to have more purposeful first action for those tax payers who won't pay the debt in full on due date. But this is a cold start problem. They are new to the system, and we need to identify and take the early prevention to remind and to warn them to pay. And the third objective is about like right time to call, which means suggest the early start to engage a taxpayer when they are more likely to have the time to to discuss with the government about the tax and inform the debts, outbound contact recovery strategy, basically who should call and at what particular time, and for each outbound call staff, what would be the better, arrangement for them to improve their right party connection within certain kind of constraints. So for the problem I just raised early on, it was quite specific. So what we actually work on is to understand how the client and their behavior actually, interact with each other, how we can change their behavior so that we can change the client profile and change their circumstance and vice versa, and to work out, specific strategy in terms of the behavior and the behavioral sequence to achieve the goal, to improve the on-time and full payment, full lodgement, and also to organize active tailored data prediction, recovery, prevention, and to enable the intelligent action-taking recommendation, and certainly to make the government action and policy and process more cost-effective. So now I'm going to explain more details about how we achieve that, and certainly do that. So we need to apply this smart data and behavior in this particular case to improve the data client decision, service, and compliance, and to answer some specific questions like when to engage which clients, and what is specific personalized intervention, and what are the more cost-effective intervention, and what are the next best intervention. So the previous engagement model I show here, so a group of the debtors, and when the debt are created, and there are a sequential of actions will be followed from, send a reminder letter, give them a call if nothing happened, and also like to arrange formal action, even like garnishing and director penalty notice, etc. So that was a previous linear way to engage a client. And now move to more non-linear client engagement model. And for those people who own the debt to the government, so what we do is that we have multiple channel, a multiple way to interact with them. But before that, we have to understand, what are their specific, profile and the circumstance, and if the people with, future opportunity to cause debt, and whether we can send them some softer SMS message, and to just remind them, and then they can pay, the debt back, and then the problem solved. If the SMS message was sent and the problem was not solved, and then the system, the analytical model will suggest what would be the next best action for this kind of people or for this particular client, right? And for some other case, like small business owners, they own the debt, owe the debt to the government, and then what will be the SMS message we should customize, and if they pay back, that's good, but if they don't pay, so what could be the next best action for those particular, taxpayers? And for those very serious non-compliance, and we have, from the day one, actually create a much formal action and to be applied on them. So the previous model certainly is a linear collection model with treatment pathways, and is a single risk-based differentiation approach. It's one big macro campaign approach as well. And the system is hard-coded. But the current system actually highly segmented, and it engages data in the right way at the right time, and to conduct multiple campaigns, and system is quite business configurable. And the goal here is simple, is to identify the behavior insight and to do the insight-driven actions, and to do to segment the clients based on their behavior dynamics, their change, and recommend interventions before a debt occur, and the right treatment on the right clients at the right time when the behavior evolves. And also, for a particular taxpayer, I want to find the most suitable and effective, intervention approach to distribute their appropriate resources to manage the debt as needed. So I give you a specific example here. So if a debt is happened, so this is a timeline here from when a taxpayer pay or lodge their tax claim, and if a tax debt is created, and then we identify, so use a model called POT model, is a pay on time model, and to identify whether this taxpayer likely to pay. If likely to pay, we want to send a message. If this client unlikely to pay, and then we'll customize the message. The SMS message in terms of different kind of scenario, and that could be like a payment reminder, or could be even like some other information to be included into their SMS. And after that, so we look at the performance, so whether this client actually pay back, and if not a payback, and the risk-based and analytical model will be triggered, and that will create soft SMS nudge and to reminder, and if it doesn't work, and then form as MS nudge will be triggered as well, and then it come to another situation, then this data will be existing data, but there's no previous information about the debt treatment, the best way, and then there's another model called PF, purposeful foster action model will be triggered, and that actually further recommend a different kind of treatment strategy to intervene with this taxpayer. And more specific example here is that, so if so for those debtors, And after before the due date, there are pre-due date message will be sent to them to remind them. So after the due date, and there will be like after due date, SMS will be triggered and sent to those who have their mobile number with the government. So for example, like a particular taxpayer, Dave, and after the due date still own the government money. And so the model will actually try to understand, this is Dave a new data? If Dave is the new data, and then we need to trigger the first action, treatment model, and to decide what kind of treatment for the first action need to be triggered, and then we'll deliver this action. And then after deliver this action, so we will see, what will be the performance, what will be Dave's response. If Dave actually pay in full, that's all good. If not, so understand whether we can find a better way for him to pay partially or if no action, and then we further trigger other, models, and that will actually to suggest what will be the next best action, and then the treatment decisions and the actions will be taken, and further look at, whether look at Dave's response, and based on Dave's response, further to, to suggest other next best action. So in doing this, we involve different data set, internal and external data, like, outbound core data, inbound core data, the business data, demographic, core list status, etc., and suggest actions. Basically, like what will be the best time, and recommend the hour with maximum score for that particular client, etc. And the question really we need to answer here is what is the right time to call that particular client, and the outcome is that we show almost a 10% increase in the right party connection. So the model we use actually is quite minor. It's involve like a high impact behavior analysis, high utility behavior analysis, non-occurring behavior analysis, and deep models as well. And we use SAS, R, Python, Python, Spark, TensorFlow, etc. And I have some example for you now. So there's one example here is that is explain what is a self-finaliser. So self-finaliser are those people who cost the debt to the government, but essentially government take no action, and then they pay full back to the government. So they are called a self-finaliser. And for those self-finaliser after the due date, and then basically for all the taxpayers, and we actually segment them into 6 data levels, data level 1 to 2. Low level, and then data level 6, actually high data level. And for, as shown in this diagram, for those different level of taxpayers, and the low level, they're actually, self-finalized rate is much higher than those non-self-finalized, non-self-finalizers. And so I needed to take different actions, differentiated, actions on different people to based on their behavior and the circumstance. And this shows actually after applying the model and before applying the model, the difference here. And the red one shows actually their actions per case taken on those taxpayers and pre-deployment. And the green one shows, the actions, per case post-deployment. So you can see here, so within the 12 weeks, so in the first few weeks, actually, for those, by using the model recommendation, actually, take much less action there, much less. But, by week 12, actually, the self-finalizing rate is almost the same, as as the previous without our model. So which means we can significantly reduce, the action on those people. And this photo shows actually after applying the deployment, after applying the model here, and you see the self-finalizer and the non-self-finalizer, and the difference, within the 12 weeks. And actually you see the significant gap, here, and that actually the improvement caused by the model identify those self-finalizers. And we apply this and basically do A/B tests. And for the two groups, we control the self-finalizing rate. And we can see for the group apply our action model actually can get to 24% of reduction of their actions. And we further actually change the government policy and the process and suggest, for those, people actually, this red line shows the self-finalizing rate. So initially, those people, they actually is non-self-finalizer, but the government actually, overact to them, put much more resources than needed, right? And then these guys actually later, is very high non-self-finance rate, but actually government is under action on them. So we actually suggest, to shift the resources here from this part to this part, and then for those tough non-compliance, actually from the very beginning, and we take a firm action, and this actually shows saving would be something like 10 million for 5 years, and another is 37 for 10 years. And another example, like a right time to call, like just a customize the SMS, and this shows an example actually reported in the government report, and for 7.5 million of taxpayers, and we analyze 1.3 million taxpayers not expected to pay on time, and this actually involves 1.3 billion of dollars, and we identify 43% of them actually have their valid mobile number with the government, and then we send 250 SMS customized to each of them, and that actually save $800 million paid, but each SMS just costs 9 cents. So the campaign shows actually as the customized SMS actually can make a difference and to encourage the taxpayers to pay on time and pay all out and pay full. But those without SMS and have much higher chance they would pay later or no pay. And this is a more recent report actually shows in 2016 actually using the SMS nudge, and for those people who usually they won't pay on time, and by using the technique we developed and suggest, and that actually secure 1.4 billion on or near on-time payment, and from those habitual later payers. And further, you can find some of the report in the OECD report about smarter tax management, and that also involved the work we did for the government. And there are further report shows that the government actually is changing and to be more active and to treat the engaged clients in a fair way, and to encourage the taxpayers actually to pay it back in a more active way. And the government actually tried to reduce the level and incidence of outstanding taxpayer debt through the early intervention, early prediction, and by customized SMS to those, especially to those habitual later payers. So this has been widely used in the recent years in Australia, and to manage the taxpayers' behavior and to understand their behavior, and to discover those taxpayers, what could be the right time and right action, and then in a non-linear way to interact with them. Now, I just briefly share the methodology behind this from the high-level perspective. So it's about the behavior informatics. So what we did actually from two perspectives. One is that is behavior representation and reasoning. So that involves actually the behavior representation, behavior modeling. And when we build a model, and how do we check the model, make sure the model is correct, is proper. And now we do the behavior reasoning and aggregation. And this actually is more like from top down, which means we have to understand the domain very well. And from another perspective, there's given the data, the client, their behavior, and taking a bottom-up approach, and we construct the behavior data and suddenly engage the external data as well and domain knowledge, and we develop and discover the behavioral pattern, the abnormal behaviors, non-occurring behavior, and the behavior impact and behavior utility, etc. And use the outcome to change the behavior in order to to generate a high impact or high utility. So that's the behavior learning and behavior mining, which is bottom up. And behavior in our case actually refer to a subject undertake action on object at a particular time points or place, and within certain kind of context and environment and constraints, and generate their impact. So that involves behavioral performer as well as the social information and the intentional information related to behavior goal, behavior belief, and a plan, and also the behavioral performance related to the impact and the status. So essentially, what we do is that is to create a vector-based behavioral sequence. That's the behavioral matrix. So the process we usually take is to work on the business applications, and then we have to transfer the existing data, especially from transaction data to behavior data, so that we can actually see the behavior in the data, because the current the transaction data is not organized in terms of behavior, right? And so that we can further do the behavior pattern or non-occurring behavior analysis or behavior impact utility modeling, etc. And when we get the outcome, and then we can present the behavior and then convert that into business rules and then incorporate it into the system and to change the customer behavior. And for example, like group behavior, so often related to the government debt or tax or social welfare. Actually, you have one customer got a different behavior related to this customer, and some of the behavior may be associated with that and some without that. And then this may be associated with another client and that client's behavior. And there may be relationship between this customer's behavior and another customer's other behavior sequence. And so we have to model this kind of group behavior. Essentially is to convert this to a behavior feature matrix. And in the behavior feature matrix, and we try to understand for each client's behavior, and so what is the relation between their behavior? And then from another perspective, so what is the relation between the different people's behavior at a particular time point or time window, and to model such group behavior, and so that we can have better understanding, so what is the best action for one client's behavior, but also, that could be related to another client's behavior. So, like an example for the Social Security, so this is like a group of pattern here. So for people whose age is 65 plus, and the government arrangement may be different on them. And then we look at for the same arrangement, like withhold or irregular, for them to pay back the debt. So what will be the risk level for them? If they take different repayment behavior, like cash post or withhold. So you'll see here, so one actually is associated with a high risk level, another with low risk level. And then we convert this to an intervention table. We see if this withholding behavior is actually associated with high risk level, we want to change it to cash and post, ask the clients to take this arrangement action, and then so that we can change the risk level from high to low. And another example here is that is related to different behavior. So if we have a behavior like this, so usually we see got a different behavior and the outcome, the impact is the same. So we have no idea which behavior is more important in this group, right? Because the outcome is just the same. So try to understand, develop technique to understand. So which behavior actually is important, and then we can develop and find this behavior and develop the relevant the knowledge, insight from there, and convert that into the business rules, and then incorporate that into the system. So finally, we summarize. So I just highlight 3 keywords here. One is behavior. So that's about so who did what at what time and how and why, etc. And second is about the behavior in informatics. It's basically to represent behavior, to check behavior reasoning, and to do the aggregation of behavior. And now also the behavior analysis learning, and to understand the impact utility of behavior and why some high impact behavior didn't happen, but still very important, how to understand such kind of non-occurring behavior, for example. And also the behavior insight is to understand when and we can do the early detection, prediction, and prevention, and what kind of customized, personalized engagement management we can apply on the particular clients. And that's it. Thank you very much.